Hello everyone. So this is problem number 31 in the series of PYMT, the problem you must try. This question was sent to me by one of my students, and the question is from topic series. The question says that let a sequence of integers I1, I2, I3 and up to In, by the way, is defined by this I1 is equal to 1 and In plus 1 is 1 plus the product of the previous all n integers, and this is defined for all n greater than equal to 1, and there are two other sequences defined in a different way, that the Hn is the summation k goes from 1 to n, the reciprocal of Ik, and the Pn is the product of all this Ik reciprocal. So we have to evaluate H 2018 plus P 2018, and if you solve it correctly, your answer should be 2. So before you see the solution, I recommend you to solve this question by your own. So let's see how we can do it. So understand this first given information, that is In plus 1 is equal to 1 plus, and this thing I can write as in the product pi, and let me write k goes from 1 to n Ik. Now you notice that I can write from here as the product k goes from 1 to n Ik is equal to In plus 1 minus 1. Now one thing is important, that you can see that if these are the products of all integers. If you take the reciprocal of Ik, this product, whatever result will come on the right hand side, this will also be reciprocal, because this is the I1 into I2 into I3 and so on, and you are taking the product of all these products. So I can also write this thing as I have pi k goes from 1 to n, and that is 1 by Ik is nothing but 1 by In plus 1 minus 1. And you see, this is the exact thing given I have for Hn, not Hn, Pn. So I can write this, the Pn value we found. So Pn value is 1 by In plus 1 minus 1. Now the whole drama we have to execute on this Hn, and how do we determine the value of Hn? That's the important point. So let's see here. The Hn is, I have the summation k goes from 1 to n 1 by Ik. Notice this is not the sum product, this is sum actually. So how do we apply the summation here? So whenever this kind of summation appears, our first what we call direction to think in is to see whether a telescopic kind of sequence is happening or not. If it is there, then it will be good for us, otherwise we will think in a different way. So first guess is that we make the telescopic for this 1 by Ik or not, so that this will get cancelled. Okay, so now notice this index is a little bit confusing, and that's we have to understand very carefully. Now this is Ik here, so this is In. Let's see here what we have. This we have to determine first. So we have this In plus 1, let me write one more time, 1 plus pi k goes from 1 to n Ik. Now from this I want to find the Ik here. This is Ik given, and from this information I want to find Ik. Now notice this is only the matter of index. The k goes from 1 to 1. Even if you write this as a r goes from 1 to n, it doesn't matter. So since there is the introduction of ik, I'm just changing the index, this k values into r. So I'm writing here, let's say I k plus 1 is equal to, and this I'm writing as r goes from 1 to k, and this is ir. Because notice that if here is n plus 1, I have to write there as n, and now the index was k before. But I want to write ik plus 1, so I will write here k, and that is ir. This is not summation, by the way. I did a mistake in writing this thing. Otherwise, will be blunder is a pi. Since I have to evaluate this ik, I need this ik, by the way. So I will replace this k plus 1 with k minus 1, with k minus 1. So that will become ik, and that will give you 1 plus the product. R goes from 1 to k minus 1, and that is ir. Now from here, you can notice one thing clearly, that there is one term missing. R is equal to 1 to k. If I have, I can write this entire product as here. If I have r, that's a k, goes from 1 to n. Let me write in terms of r, then you will understand perfectly. So this is nothing but, I can write here, let's say, I of, I'm writing this thing there in terms of r. So I r, and this product pi goes from, r goes from 1 to, let's say, k. Then only we can write I of k plus 1 minus 1. In the same way, what I'm thinking is this is up to k minus 1. So if to k minus 1, I need extra value at k for this term. If I have this thing, I can safely take this as ik plus 1 minus 1. So I'm doing the same thing, and this whole drama we are doing just to find out the telescopic of 1 by ik. So I can write here ik, and again 1 ik here, multiplying with this, and this is ik here, and this will give you summation. R goes from 1 to k minus 1, and then ir, and again ik. So you can notice that whatever it was missing to get this k minus 1, and we have, and then we can write this thing as ik plus 1 minus 1. So let me just arrange it. This is ik, and this is ik again, and this is going to be ik plus 1 minus 1. Now the whole idea is to write this thing as a 1 by ik. So for that, let me just take this ik this side, and I'm taking ik common. So this will give you ik minus 1. And why I was playing this whole thing? Because you notice that I am a little bit closer to get the telescopic for 1 by ik. Now there is one problem. If you want to write 1 by ik here, we have to be very careful. From there, if you take 1 by ik in such a, like a, not so smartly, what we get here, 1 by ik is equal to 1 by ik minus 1 by 1 by ik plus 1 minus 1. Now this is one very wonderful thing. If I have the product there of the ik, you can notice that this will get cancelled. We are multiplying this, but I need the summation because of the reciprocal of this. This is 1 by ik, by the way. If I have to find the product, then it will get cancelled. But if I need the summation, I have to think a little bit carefully. And what careful steps we have to do there is just take the reciprocal here. So if you take the reciprocal, you get 1 by ik, 1 by ik minus 1, and there 1 by ik plus 1 minus 1. Now this has a very wonderful thing, that the difference is there 1, so I can write here as 1 by ik minus 1 minus 1 by ik, and this is 1 by ik plus 1 minus 1. So I got the value of 1 by ik, 1 by ik, yes, is equal to 1 by ik minus 1. This is not k minus 1, by the way, you understand. And so 1 by I k plus 1 minus 1. Now you notice that this is exact telescopic what we are looking for. So I can write 1 by ik at the place of 1 by ik here in the hn. So I'm taking this hn here and again substituting these values and summing up. One thing you have to be very careful, that the I1 is already given 1. So this will start not from 1, because this will become 0 there. It will start at from 2. So how do we make it happen? I can write hn in this way, that 1 at the value 1, and this I'm going to start k goes from 2. So this I'm writing 2, k goes from 2 to n, and that is 1 by ik minus 1 minus 1 by ik plus 1 minus 1. So if we add them up, what we get is 1 plus, and we get the first term here, that is 1 by 2. At the 2 it has become I2 minus 1, and minus 1 by, at the place of k it will become n, so n plus 1 minus 1. So this is the result we got after summing it up. Now notice that the I2 is missing there. So I2 we can find from the very beginning, because it's given that it starts from n is equal to 1, and if you take n is equal to 1, this will become I2 is equal to 1 plus, and in this sequence of the product I will get only I1. So this will become I1, and I1 is already 1, so that will become 2. It means if I2 is 2, I will get there, that value will be 1 plus, that is 1, and minus 1 by in plus 1 minus 1, and this is hn. But notice one thing again, this is exactly what we have already evaluated, that is pn, correct? So I can substitute their pn value. So what I got is the hn plus pn is equal to 2. It's independent of the values of n, means whatever value you substitute in, this hn plus pn will be always 2. So no matter what you are substituting the n, whether it's a 2018 or 2026 or whatever, that value should be 2. So this is a very smart manipulation we have to think, and it doesn't come directly. We have to think it wisely. The important point was how we change the index and how we manipulate the product to get into the summation telescopic. So that's all for today's video. See you in the next video with some other problems you must try. Till then, stay math active.